Hello, you are watching a video for the solution to question number 9 off this 2.3 homework, where we are trying to find the domain of functions when we're given the actual formula for the function. And we're going to have to think of a couple of cases where the domain is not just going to be all real numbers, and those cases are like in part A where we have a square root, or also in part C over here. Of course, in B, we also just have a simple square root, and so that would be the same situation as we have for A. But for C, we have another unique situation besides the square root, which is that we have a division taking place. And so the rules that we need to keep in mind are that we can only take square roots of numbers that are greater than or equal to 0, and we can divide by every number besides 0. And so we'll take C as we come to it. I want to start with A. Since it's alright to take a square root of every type of number except for ones that are less than 0, what we can do to find the domain is we can just take this part that's inside the square root that we need to be greater than or equal to 0, and we will just do that. We'll set it 36 minus t. We'll say it needs to be greater than or equal to 0. And then we're interested to find out which t values this will work for. And by following some normal procedures to solve this inequality, of course we could just add t to both sides. There are any number of ways that you could go about doing it. This looks like a direct way for me, and so after we add t to both sides, it will go 36 is greater than or equal to t, because of course this t will cancel. Another way to think about this one, we could flip it around and say t is less than or equal to 36, and sort of a picture for that one. T being less than or equal to 36 means if we start from 36, it can be equal because it says or equal, so it would include the value 36 on this number line. This happens to be the t line. And it needs to be less than or equal to this, so any of the numbers that are less would also be good for us. So it's these numbers coming all the way from negative infinity up until 36. The domain that in interval notation is coming from negative infinity and goes up to 36, and then it will stop. If we take any values greater than 36, like 37 for example, if we try to plug it in here, it will go 36 minus 37 inside the square root, and that's negative 1. So it goes square root of negative 1, and that's not a real number. And so any of these values over here, they don't work. And what about this next one? It's still a square root, and we want to ensure that this stuff inside the square root is greater than or equal to 0, so we find out which t values will satisfy this inequality, where t minus 36 is greater than or equal to 0. And this time, instead of adding t, what about we add 36? That will cancel this one, and then it will go t is greater than or equal to 36, and that's our domain. So if we thought about it as a picture, I always like to draw the pictures for these domains and then try to translate them into interval notation. It will help you in the event that there are more than 2 intervals. Sometimes there are 3 intervals, but it happens pretty often that people will forget the middle interval, or maybe it's even more complex. It can have as many intervals as possible. We don't want to skip any of them, so if you draw a picture of it, you can make sure that you have an interval in the interval notation that corresponds to every interval that you see on your picture. In this case, there's just one interval. It starts at 36 on the low end, and it just carries on going everything more than 36, so it goes up to infinity. And now we have C finally, where we're going to have to consider both cases, the one where we have this rational sort of a format as well as the square root. So we need to satisfy 2 different rules. We need to satisfy that this stuff inside the square root, the 36 minus t, it needs to be greater than or equal to 0. So if we solve that one, it's actually the same one from before. So we'll end up getting that 36 is greater than or equal to t, or else t is less than or equal to 36. So that would be all of these values that we had before. But then we need to pay attention to the fact that we're dividing by this thing, so there could be some dangers there for a certain t value. We need to find out which t value will make this denominator be 0. So whenever we have a division like this inside of our function, we need to find out if there are any values that are going to make this denominator 0, because that's not allowed. And so this denominator is square root of 36 minus t. If we set it equal to 0, we will find out which values need to be excluded from the domain besides the ones that we found before. We're already excluding all of the values that are greater than 36, but there might be something else we need to exclude here that would cause us to divide by 0. So I set the denominator equal to 0. The solution for this equation we also cannot have in the domain, but we can have everything else. And so everything else that we already had before, all of this stuff. Now to solve this one, it goes square root, and so we should square both sides to get rid of square root. Square root squared goes away. Goes 36 minus t equals 0, because 0 squared is 0. We can add the t to both sides. It's going to go 36 equals t. So actually we cannot have the point 36. So we need to take this domain that we had before, everything less than or equal to 36, and we need to, see on 36, we need to exclude this value, because due to this division that we had, we could plug in, I would want to say all the values, but it happened to be, I'm actually going to just get rid of this that I'm drawing right there. We want to take this domain, which I'm going to write it into interval notation. It's coming from negative infinity up to 36, but it's including 36. So it would go like this one. And we want to now also exclude the point 36. And so instead of including it, like by putting the square brackets, we should write the interval notation this way up to 36, but then exclude 36 by putting parenthesis on 36 instead of the square brace. And that will be our domain, negative infinity up to 36, but not including 36. And that would do it for this problem. These are going to be how to do the domain for all the functions. You look for if there's a square root. If there is, you do this. You take what's inside the square root and make it greater than or equal to 0. That's going to be in the domain, all of the stuff that solves that one. And then if we have a division, we take the way we did it here, we set the denominator equal to 0. We solve for that one, and that stuff must be excluded. Other than that, any other kinds of functions, the domain is all the time. I will say all the time, almost all the time, because we could also have logs or something, but the functions that we're dealing with so far in 2.3, by default, the domain is all real numbers, but you can just check that yourself. Thinking about it, are there any numbers that are not possible to plug in? And there are not many rules to look for, just the square roots and the division. Anyway, I hope it's helpful, and I'll see you on the next video.